Group. This is the Wednesday, January 10th, 2018 edition of our little weather get-together, and we're happy to have you all tonight. It's been a much calmer weather week across the Southeast and the Carolinas, and we'll talk about that a little bit later on. But tonight, our guest, we have Andreas Prein. Sorry, I knew I was going to mess that up, but Andreas Prein, he will be with us tonight. He's from NCAR out, and I think he's out in Colorado tonight. So we're going to be talking about summertime thunderstorms. I know probably kind of far from your mind right now with the winter season ongoing, but we're talking about summertime thunderstorms. Are they getting stronger, and are we getting more rain and flooding events out of them? So that is our topic tonight. But before we dive into that, let's go over a few housekeeping rules. This is a live broadcast, so if you have any questions throughout the night, you can send them our way many different ways. We're on Facebook Live, Periscope, on our YouTube channel, as well as I think that's it. Periscope, Facebook Live, and YouTube. So if you're listening on the rebroadcast of the podcast, we'll share some information at the end of the show how you can get in touch with us. So with that, I will pass it around. Shay, I think we're going to talk a little bit about the weather before we get into the topic tonight. And Shay, you went from winter wonderland to almost summertime heat in the span of a couple of days. So how is snowy Charleston now?
I'll tell you what, that was a long cold spell. In fact, it was our number one longest cold spell for low temperature averages, mean averages. I think it was a 9-day stretch total. I know there was a 7-day stretch in there. And then we had the second lowest high temperature mean average. So, this was a very cold week leading up to the snowstorm that we just had. And I'll share screen let me see if I can find it here. Let me switch over to our snowfall totals and make sure you can see that, see what I'm talking about here. What we had low pressure that developed off of the coastline, off of Florida, developed in the Bahamas and headed straight north. So it wasn't quite your typical Miller A setup. We sort of tried to, find out what kind of system this was, what kind of pattern it was. And we think it was some sort of hybrid, but either way, these are the kind of lows when you get this kind of cold pattern in the southeast that dump snow along our coastline. So it started out as freezing rain in the morning, switched over to sleet, and then quickly transitioned to snow all day. We had it until about 7:30 or 8 o'clock at night. Most places got 4 to 5 inches inland, just inland along like Somerville areas, Goose Creek, Hanahan, Walterboro. We got, and some of these spots are saying 6.8, but we did have 7.3 in places like Somerville. So there's a few spots that had a little bit more. These are averages for these areas. But that's pretty significant for Charleston. Not only was it significant for us to see that much snow at one time, but it was a dry, fluffy snow, not like our wet snow that actually stuck to the ground in full. And it stuck for about 5 days before we started getting some real melt on the street. So school's been out all last week. It's just been an icy kind of everyone's been iced in. Everyone's been, had cabin fever. Kids just went back to school today in Berkeley County. Now that the streets are clear. And yesterday our temperatures went up. We got 3 degrees within our record high of 75 degrees. We got to 73 degrees yesterday. And the record is 76. So it just shows you how volatile, how diverse the weather here in Charleston is. But I tell you, that's one of the longest cool downs I can remember ever here. And it was down in the teens at night and in the mid 30s in the day at best. And once that snowpack hit the ground where we were supposed to get 40s for highs, it kept it down. So you had your what's called surface albedo, which reflects sunlight. And so when you have lower albedo, you have more snowpack on the ground, which reflects the sunlight, and then your temperatures are cooler as a result. So that snow stuck around for a lot longer, which is very rare for our area. So very rare event. Overall, we're getting out of it now. Most people are starting to get out of their colds. I know I had the flu and the cold over the weekend and just now getting out of it. But it was a really unique event. Really, really fun. Lots of really good pictures, lots of fun. The kids had fun. Lots of snowmen and lots of wrecks too. So hopefully a lot of folks learned a lot from this event as well. So enough about our weather. Scotty, back to you. Let's go around the other panels.
Well, Shay, the panel, they wanted me to ask you, and they wasn't brave enough to ask this. So they want to know, were you in your flip-flops and shorts yesterday with snow on the ground?
Absolutely. Absolutely. Board shorts, okay? Got to have board shorts.
I'm telling you, where else can you get 70-degree weather with snowpack on the ground? So
I know I almost went to the beach, right? With a beach chair, but our sea surface temperatures were about 41 to 42 degrees. So that's not going to feel too good with onshore flow.
No, that's a little chilly. Well, thank you for that
Yeah.
report, Shay. Let's go over to James, who's in Charlotte tonight. James, yourself and myself here in the Western Carolinas, we thought we was going to flirt with a little bit of ice on Monday, but that never materialized. But we finally have warmed up. I know you guys also in Charlotte got close to 70 degrees yesterday and today.
Yeah, that seems to be the trend that we beat the forecast each day by a couple degrees, and I'm not complaining. I sat outside yesterday enjoying the weather. As some of you may know, I've got a inside thermometer that sits up here in my home office, and I had turned the heat off yesterday, and obviously wasn't going to turn the air conditioner on, but I looked, and it actually climbed almost to 90 degrees inside my office yesterday. So, hello, January. Yeah, I've been enjoying the last few nice warm days. We're in for some clouds and rain, but I will take it over the freezing temperatures. Scotty?
Yeah, it's been a refreshing warm spell here the past couple of days. Well, I'm going to get to Eric in just a minute because I know he's preparing for the next wintry event. But let's get to Ashley, who's in Texas tonight. Ashley, how's things been there in the Lone Star State?
It's pretty good. We've been rebounding from all those cold temperatures. So the past few days and for the rest of the week, we're looking at 60s. So it's been mid 60s here. Didn't even need a jacket. A lot of the people in town for AMS in Austin have loved the warm weather we're having. And really, it's probably going to be 60s until this weekend. We're going to get a cold front that's going to come through, and it'll really impact our low temperatures into the 20s, but we're still going to rebound into the 50s. So there's not really anything on our radar as of right now. So jacket
Ashley,
weather.
Good point you make there. I've following a lot of the AMS conference on Twitter, and a lot of folks have been commenting on how nice and warm the weather's been there in the Texas area. So a nice refresher for everyone who's been in the deep cold. And talking about that, Eric, you guys are getting ready to prepare for a little wintry weather yourself in Memphis.
Yeah, I think it's going to finally be our turn. And I thought Ashley was going to say it's going to be in the 60s here until it gets to the 80s, but she was going the other direction with that. Yeah, the 60s are here, though, right now. We got to 60 today, first time since probably mid-December. We've been hanging in this cold spell. Christmas through the first week of January was one of the top 5 or 6, I think, coldest on record. So definitely felt that Arctic blast coming through. And then we're warming back up tomorrow afternoon. I think we may get to 66 or 68 right ahead of the front. 12 hours later, we'll be down to 32 and still falling. And so it looks like we're going to get, we're preparing for some ice here in Memphis. We might get a little bit of snow, but it does look like freezing rain as that front comes through and drops the temperatures. Rain will be falling pre-dawn hours Friday, and might get a little sleet mixing with it. And then as the low levels cool, go through the sleet, and then maybe a little bit of snow, and then wrap it up. But potential is there for maybe as much as 1/4 of an inch of ice here in Memphis, and that's nothing to sneeze at. Definitely, we're going to have some. In fact, a lot of people probably be sneezing after that with more flu and everything else that'll be going around. But yeah, it could be somewhat significant. So we'll see how it plays out. Hoping for the best, and maybe just early enough in the morning to get those schools canceled, let everybody stay home, and they can have a 4-day weekend with the MLK Day on Monday. So.
Well, Eric, I certainly hope you guys get more snow than sleet. That's what we were worried about here in Charleston, was getting more freezing rain and sleet buildup before the snows. But we only got about 1/10 of an inch, maybe a little bit more than that. And then once it converted, there were no issues. I mean, there were very few power outages around town, and maybe just a few pockets here and there of neighborhoods. But yeah, I hope the best for you guys. I hope you get more flakes than anything else.
Yeah, I certainly hope so. It's going to take a good 1/4 of an inch to cause too much in the way of power outages, but a tenth or so is gonna mess up the roads and the overpasses and all the flyovers and stuff we have around here. So
yeah, no fun messing with freezing rain. That's the least wanted precip in the wintertime as possible. So let's bring Andreas in. Andreas, we want to welcome you to the Carolina Weather Group. First time joining us. And before we get into tonight's topic, we always ask our first time guests to tell us a little bit about themselves. So tell us how you got into this crazy weather world that we all enjoy being in.
Yeah, thank you for having me, Scotty, and it's really an honor to be here. So I'm originally from Austria. I did my PhD there and my master's studying meteorology and physics. And I always was fascinated by weather. And especially over here in the US. I think you have much more interesting weather than we have in Europe. So with all this severe convection and hurricanes and also the big winter storms. And 3 years ago, I moved over to Colorado to work at the National Center for Atmospheric Research. And yeah, I started to work more and more on US weather. And that's how I got involved in this mesoscale convective system and also hail modeling and things like that.
And so, Andreas, you've been doing a lot of research about, you're talking about the convective thunderstorms, especially something that we deal with here in the Southeast a lot is pop-up storms in the spring and summertime, and systems that we call MCSs. And before we get into your research, maybe a lot of our listeners who may not know all the weather terms, how about you kind of give us an idea of what an MCS is and then go into the research that you've done?
Oh, yeah. So I think there are several definitions for MCSs, but you can think about it as several thunderstorms that start to organize, that start to act together. So often they start as single cells and then they start to organize, intensify, and get really big. So that the way we define MCSs in our studies is we want to see a very large rainfall area, at least 60 miles in diameter. It has to live for a longer period, like at least 4 hours. And it has to be intense enough. So you have to have enough rainfall, which basically says it's a thunderstorm. It's severe convection that's going on. And these systems are really fascinating because they can be really, really big. They can be as big as major states. So they could cover both Carolinas, the cloud shield of these MCSs. So maybe I can show a quick animation that people can get a feeling for what I'm talking about. So in our study, we're really looking at the rainfall from these MCSs and the related flooding. So this is a case from, I haven't shared it, sorry. So, okay.
There you go. We got it. And
Okay,
I'll go ahead and present that to everyone and you're good to go.
Great, thank you. So this is an extreme rainfall event that happened in 2016 in Virginia, in West Virginia here. And what you see here is a radar image. And what we're looking at, these blue colors are showing you deep clouds. So they are really high clouds related to thunderstorms. And you can see how this MCS, so this MCS is basically this big blob of blue that you see here, is moving into West Virginia here and stays in West Virginia for more than a day and drops tons of rainfall, and then it's moving away from it. So this is exactly the type of storms that we're talking about. You can also see another MCS here forming in Colorado and then drifting eastward. So MCSs are pretty frequent actually in summer in the US. We have MCSs almost every day, and they are really the major source of rainfall in the US. Up to 60% of the rainfall in the central US is coming from MCSs. But on the same side, and if they are extreme, they are also related to most of the severe flooding events in summertime, in the warm season. And for example, this event in West Virginia was one of the most deadliest flooding events in recent history. I think 16 people died in this event. So they can be really dangerous and very destructive.
And Andreas, through this research, you sent us your research, and it was showing that these storms are producing 15 to at times 60% above normal rainfall for a lot of areas. And what do you think is the main driver of that? What causes us to see those more intense rainfall out of these MCS systems?
So the reason for that is that the rainfall from MCSs is actually closely related to temperature in the air. So as air is warming up, you can store more moisture in the air. So you can think about air like a sponge. If you have warm air, the sponge is larger and you can store more moisture in the air. If it's cold, like in wintertime, you don't get very strong downpours because you have very little moisture in the air. So if you have very warm air, and if it's humid enough, you can get very strong rainfall. So this is directly related to climate change. So what we see all over the US, for example, is a strong increase in temperatures over the last 30 years. And at the same time, we see a strong increase in moisture in the air. So in this moisture is really the source that feeds this MCSs and that drives them. And you can think about, you have more fuel for these MCSs if you have warmer temperatures. And that's why we are concerned about climate change, and also in the future that these MCSs will get more and more intense as we warm up the globe more and more.
Now, Andreas, how do you connect this with the subtropical jet stream? I mean, you talk about a lot of warm air aloft. You talk about atmospheric rivers of water for the most part. I mean, some of that map you showed, it looks almost like a monsoonal trough at one point there. I mean, I know there's frontal activity involved, but that's a lot of moisture. I mean, what is the connection to the Pacific, maybe, or is it just that much energy in the central U.S.?
So the central US, the jet is also important. So there is this term which is called ridge rollers. So these MCSs are often forming along the subtropical ridge in late summer, and then really going along the ridge line following the jet. But I think the most important driver for this, or the most important moisture source here, is the low-level jet in the US, which is basically a daily feature building up in late afternoon and late evening and early evening, and transporting a lot of moist air from the Gulf northwards along the mountains, and then it's moving towards the east, somewhere around Colorado. It depends on the season. In late season, it can propagate further northward. And this moisture transport is really the main source of moisture for these MCSs. And this is also what we see in observations. So we see that this moisture transport is increasing over the last 30 years, which is closely related to having more intense and more extreme MCSs.
Wow, very interesting. So another question that you're talking about the low-level jetting at nighttime that helps transport the moisture that is produced in the daytime during heating, radiational heating. And I got to ask, I'm going to share screen here. I want to ask if this has anything to do with it. Now, for our audience out there, this is urban heat island effects, which are lots of development, big cities, metropolitan areas that give off a larger heat signature over areas, and they actually provide superheating aloft over these metropolitan areas. Nearby lakes, rivers, and all that can feed into it. But would something like this also be in play with these more intense MCSs that we're seeing today?
It can be part of it. I think it's not the main driver. So what these urban heat islands can do, they are a source of convergence. So air is flowing into the heat island and then rising up. So they can start convection, actually. And once you start a convection, the convection can organize and grow upscale and get to and develop an MCS. But these MCSs are really long-lived features. So what normally happens, so typical MCS is starting in the late afternoon or evening hours, somewhere along the Front Range in the US, and as single convective storms, and then it's organizing and moving eastward during the nighttime and growing, and then you have basically nighttime rainfall maxima in the central US. So this is so if you look into the climatology, you see it's a weird thing to get very strong rainfall rates in the middle of the night, but most regions in the central US have that feature because of this propagating MCSs.
Andres, I wanted to ask you about this similar phenomena that we see usually west of Memphis. Does the terrain? So we've got the Ozarks, the Arkansas, Missouri Ozarks, where frequently we'll see the beginnings of one of these farther east from the Front Range. Maybe in central Oklahoma, Kansas, and they really get going a lot of times in the evening, in the early overnight hours. Does the terrain from the Ozarks help to enhance that some too? And then a lot of times we see, and it's a fairly routine pattern where as those MCSs move east southeast, they start approaching the Mississippi River in Memphis, and they tend to fall apart. But it's usually in those early morning hours when they're naturally inclined to do so. And I fight that quite a bit over here with, we've got the river, we've got the bluffs, we've got all these things that are causing these storms to fall apart, when more often than not, it's kind of just the natural cycle of those things. So can you touch on that a little bit, maybe on the terrain enhancement, and then in just that natural cycle.
So the terrain can definitely enhance the systems, especially so if you so the terrain is acting as an uplifting mechanism. So if you have flow that it's impinging the terrain, it lifts up the air, and then it can lead to more convection. So the terrain has definitely a role in the development or in the intensification of the systems. And the second question, I think what's really happening here, that you see this also towards the north. The Mississippi Valley is really somehow the border where these MCSs fall apart. And I think it's really related to the life cycle of the systems, since they basically eat up all the energy during the night, and then in the early morning hours, there's not a lot of energy left, and then they fall apart because of that. And then it takes another cycle to recover, and then we can get another set of MCSs in the next day.
Good, thank you.
And Andreas, one more now from some of your articles here. I'm just sort of picking out some information here out of your research at NCAR, and it looks like that you have some intensive modeling that you use in the form of the WRF. It's a really well-known model to meteorologists. It's called the WRF. It's weather research and forecasting models. There's lots of customized versions of this, but how do you use this for your studies, and is it actually verifying and helping with what you're doing?
Oh yeah, this is actually very exciting, I think, because so the WRF model is used for weather and climate simulations, and you need very high resolution to simulate this MCSs, because you really need to explicitly resolve the convection in the model. And the weather community realized that quite a while ago, maybe 20 years ago, where it transitioned into this, what we call convection permitting correction resolving simulations. So very high resolution, because the benefit is really to be able to simulate the severe convective storms. And nowadays we have several models that forecast over the US in very high resolution. NCAR, for example, has an ensemble-based forecasting system in 4 kilometer resolution, which is able to capture MCSs and severe convection pretty well. And the climate community was lacking behind quite a bit, because the problem in the climate community is we run our models for much longer time periods. So in the weather community, you run the model maybe for a few days, maybe a few weeks. Out in the climate community, we talk about years and decades. And now, since we have more and more computational resources, we can simulate climate in very high resolution. So you can think about the simulation that we did as a weather forecast, which is lasting for 13 years. So we basically start the model, and then we let it run for 13 years. So we get several summers in the seasons, and we have thousands of MCSs in the simulation. And this is really helpful, because then you can make robust statistics out of that.
Perfect. I have a question for you. So I read in your article that flooding is one of the biggest concerns with the increased rainfall rates, and that our urban areas are pretty much at risk because of this. Could you go on and kind of explain that, maybe some of the implications of what we can expect in cities?
Oh yeah, it's an excellent question. So so these MCSs, as I said, they're really the main drivers of big flooding in summertime, not only in the US, but in most mid-latitude regions. And what typically what we expect from climate change is an increase in extreme rainfall rates. And this increase, as I said before, is related to the increase in moisture in the atmosphere. So there is a relationship which relates the maximum moisture that you can store in the atmosphere with the temperature, which is called Clausius-Clapeyron relationship, which is basically telling you that if you warm up the atmosphere by 1 degree Celsius, so 1.6 degrees Fahrenheit, you will increase the moisture storage capacity by 6%, 6 to 7%. So there are a lot of studies that show that this is true in observations. So what we can see is due to the historic climate change that we are increasing our rainfall rates, the extreme rates, by 7% per degree warming, or but 1.6 degrees Fahrenheit. So this is basically what we already see from observations. And the models are showing us the same thing in the future. So what we did, we looked into a high emission scenario. So business as usual, if you just keep on emitting greenhouse gases as we did so far, you get to something like 4 degrees, 4 to 5 degrees Celsius increase at the end of the century, which is 7-8 degrees Fahrenheit. So pretty severe increase. So if you multiply that with the 7% increase in rainfall rates in the storage, you get up to something like 30% increase in extreme rainfall, which is very significant if you think about especially urban flooding. What our study, and this is maybe I have a slide here that I wanted to share, or a picture. So what we did, we looked into these increases. Can you see this figure?
Yes, we got it. Perfect.
So what we're looking into here is a composite of extreme MCS rainfalls. So basically, you can think about that we took several very strong MCSs, the rainfall fields, and put them above each other and average them. So what you get then is you see the center of the MCS, so the left picture is the current climate, has very high rainfall rates, up to 4 inches per hour. So this is pretty severe rainfall that we see here. And then in each direction that you're going, you get a decrease in this rainfall rates. The right picture is showing you the future climate. So there are two things that I wanted to point out, especially the center. So the maximum rain rates that are occurring here in the center are going up by approximately 30%. So this is really what we would expect from theory. And I think people started to realize that and started to plan for that. But I think the more severe change that we see in this figure is the spread of the area which has high intensity rainfall. So just compare, this is the 0.4 inch contour here in the current climate. And this is the contour in the future climate. So the area which is covered by heavy rainfall is increasing by 80%. So this is much more than just the maximum rain rate increase that we're seeing. So why this is important is if you, for example, think about a city area, and you get a system like this in the current climate, maybe only half of your city is covered by severe rainfall, by heavy rainfall. So your sewage system and your water management system has to transport this water volume somehow out of the city. In the future climate, the whole city might be covered by severe rainfall. So this is basically why we're looking. So what we're looking into in our study is this total rainfall volume over an area. So if you think about, for example, we have this example of New York City in our paper. If you look at the New York City area in the current and the future climate, this rainfall, the total rainfall increase that we can get is increasing by 60%. And just to give you a feeling for how much water that is, it's approximately 6 times the average discharge of the Hudson River. So we are talking about a lot of water that we are introducing in future MCSs. And the problem with cities is really that they have a lot of sealed surfaces. So most of the water that's falling over a city will run off, and you have to somehow transport the water out of the city. And this is very challenging because if you have an increase of 60% rainfall, you only have limited amount or resources to increase the water security systems or water management systems in the city. So I think this will be a very challenging situation if we continue to emit greenhouse gases in the way we do at the moment.
Mm-hmm. And to go ahead and build on that, do you think emergency planners, city officials, and emergency managers are aware of this change? Is there any kind of plan to try to educate them on this, to expect this kind of rainfall change?
So we had a recent press release on this article. And due to this press release, we got in contact with some city managers and water resource managers, and we started the discussion. I guess most of them are not really aware of that. So basically what the study is really showing is that future flooding might be more severe than we expect. Because if for example, if water resource or infrastructure managers would account for climate change, I think they would account for this 7% per degree warming change, which is pretty robust. But I think so far nobody really accounts for this increase in the total rainfall volume over the area. So I think there's a really need to start the discussion, and there are several articles coming out now which are looking at, for example, Hurricane Harvey. So hurricanes are a special category of MCSs. So they meet all the criterions that you need for an MCS, like big rainfall area, long-lived, high rain rates. And there's a current study that showed that the rainfall, or that events like Harvey could get much more frequent in the future climate. So there are definitely, so the science is building up that we can be pretty confident that we will have a big problem, and we already have a big problem because we already changed our climate. And I think there's a large need to start a discussion with people on the ground to really build infrastructure which is capable of dealing with this water.
I completely agree with that. And I think it's great that you started the discussion with, emergency managers and city officials. I always talk at work a lot in emergency management about how there's so much great research that can really help us every day in planning and things like that. But it's just really hard to kind of get access to that. And it's great that we're starting to build those bridges. So I think in the future, that's something that we should continue to do, try to spread these results, because you're right. If this is what the future is going to be, then we need to design our flood planning and our response planning to reflect that. Otherwise, our emergency response plans are not going to fit it, and we're going to be completely caught off guard.
Yeah, totally agree. So what we started to do at NCAR, we developed a new model which is called WRF Hydro. So it's or the National Water Model. So people at NCAR started to develop a hydrologic model for the entire US. And so what we did in our study, really purely look at rainfall. And of course, rainfall is not directly related to flooding. So there are a lot of variables that impacts rainfall on the ground. Like, for example, if you have rainfall over a city area where you have a lot of sealed surfaces, you can have a very different flood response than if you would be, for example, somewhere in Florida where you have very sandy soils. So this is something that the next step that we are trying to do is to really bring our rainfall to the ground, look at inundation and runoff, to really provide information which is as useful as possible for people like infrastructure planners, and really try to get involved with them and try to get the information out.
Yeah, I completely agree with that. One more question for me. So I asked about emergency managers and their response. How can we prepare the general public for maybe the future of what they can expect with these kinds of storms?
Yeah, this is a good question. So what we do at NCAR, we try to give public seminars. We have these press releases where we try to reach out to the press and get our research, which is publicly relevant, out into the media. So we're really trying hard to get our results out to people who are affected from them. I think there's still a lot of potential to improve that. So NCAR, for example, one of the missions of NCAR is really outreach and education. So what NCAR has is a special program which is called COMET, which where they provide courses on specific topics for educators and also for the general public, where the public can access this material and read up. It's very well done, and it's pretty easy to follow. So we really trying to make this bridge to communicate our science. But I totally agree, there is a lot of area for improvement to do this better and more extensively.
Definitely.
Yes.
And I think we can start with the emergency managers, educate them, and then we can continue on the public education from there.
Oh, yeah. Yeah, I think this would be a good way to go.
I was going to say, I was sharing something a second ago there that sort of furthers the point. Right there in that first sentence, it says rainfall events are estimated to cause more than 20 billion of economic losses. I mean, when you start throwing numbers out there, that sort of thing should grab folks' attention. So I'm assuming that when you throw these numbers out there, they're based on absolute fact and some of your findings and some of your research to back that up. But do you get more response in telling them how much of an economic impact this is going to have from a dollar standpoint, or do you find it more influential to talk about the rain events themselves and the flooding events?
Now, I think you really have to break it down to the impacts. So, and this is one way to do it. So what our group is doing at NCAR, we have strong collaborations with the insurance industry, because these numbers are really coming from the insurance at the end. And they are really interested in this results as well, because they have to update their policies and try to be on top of their game and really are interested in the research. So this is one way to go. But I think what's often really necessary, this is a little bit unfortunate, I think, is that you get hit by a big event and then you realize that you're in trouble. I think events like Sandy, Katrina, or Harvey this year, for example, are really sometimes necessary to raise awareness that we are in problems, that we are not doing a really good job in handling these natural disasters. And there is a lot of area of improvement, not only on the flooding side, but also with other disasters as well.
Okay, one more from me. I don't know if anyone else has any questions, but I know we're starting to get kind of close towards the 9 o'clock hour, but we have a lot of this activity going on in the United States being researched right now. Are there other areas of the world that are being watched for this as well?
I think all over the world, actually. So we have a lot of flooding in Southeast Asia, for example. There were big floodings in Indonesia, in Pakistan. There were really big floodings in Australia. So I think this is a global problem. And especially in the mid-latitudes where a lot of people are living. So I think this increase in flooding is one of the most severe consequences of climate change, at least for inland areas especially. So there are, especially in Europe and in Australia, I know there are groups working on similar studies and doing similar things, but we are just really at the beginning of our ability to understand how these systems might change, because as I said before, you really need huge computers. So NCAR has a supercomputer that we used. It took us more than a year to finish the simulation. So it's very computational demanding. And yeah, so but this is definitely a global topic that we are looking at here.
Andres, I've got one more for you, and I don't know if you know the answer to this question, but because I know you're focusing on the flooding, but is there other research maybe by colleagues of yours on the same types of systems and the same atmosphere that they'll be encountering that would affect things like other parts of that storm, say increased lightning, stronger winds through downbursts and so forth that naturally occur out of the MCSs and so forth?
So I'm not sure about the downpours. The winds. So the winds are still a little bit challenging. We wanted to look into winds in our simulations, but I think for the winds, you almost need even higher resolution than what we do at the moment. This is one of the main focus areas at the moment, to try to also simulate lightning in this, or at least get a relationship to lightning in the simulations. I know there was a paper a few years ago where they showed a nice relationship between lightning and rainfall rates and CAPE. So CAPE is basically a measurement of the buoyancy of air, so how much buoyant air is. And the argument in this paper was, since we know the rainfall rates will increase in the future, and we're pretty sure that this CAPE, the buoyancy, will increase in the future, you could expect that the lightning is increasing. But there's definitely a large uncertainty bar on this statement, but this is definitely something people are starting to look at.
I would think that the new instruments like the GOES lightning mapper or geostationary lightning mapper off the GOES 16 certainly would help in doing some of that research, because now you can, start to visualize that more directly perhaps than you could before.
Yeah, no, this our group, the part of our lab that does weather forecasting is focusing on lightning, and they're really interested in forecasting lightning. So there's a project they're working on. And so I think there will be quite some improvement in the next couple of years. Another area, I think, which is very interesting and people are working on is severe hail. So this system can be related to hail as well, not only those systems, but also supercells. And there was just a recent study that many regions of the US might see an increase in severe hail due to climate change as well. So I think overall, the summary of that is severe convection will be getting more severe in the future and more frequent.
Fascinating. Thanks a lot.
I think we saw that with our hurricane season this year. Holy moly, Maria blew up where it was at in the Caribbean. That was amazing. That rainfall amount right there over Puerto Rico, parts of St. Croix and Puerto Rico, was just amazing.
Yeah, and climate change definitely plays a role into that, because just looking into the sea surface temperature in the Atlantic and the Caribbean, when these hurricanes occurred, you could see that there was a clear higher sea surface temperature. This is exactly what you would expect from climate change. So there's some clear relationship, especially with the intensity of storms. We expect to get more high intensity storms in the future.
Well, Andreas, we appreciate you coming on the show tonight. We are closing in on the 9 o'clock hour here Eastern time. I do want to ask one last question. You don't do this research for nothing. What is the goal? What is you guys that's done the research in NCAR? What are your goals of? I know you said press conferences, but how are you getting this message out? What are you wanting people to start realizing or start taking a change in?
So yeah, it's a very challenging thing. So we're really trying hard to get the information out to the people. But I think, yeah, the problem is really we don't have a lot of time left. So what we think would be a safe margin for climate change is an increase of 2 degrees Celsius. And if we keep on continuing emitting, we will hit this threshold within 20 years or so. So we only have a few years left to adapt. And I'm not certain how to get this change. I think what makes me optimistic is that you see a lot of change coming from private companies and industry, like a shift to solar energy, to renewable energies, to electric mobility and things like that, which is definitely helping. The question is really if we do this fast enough. And from a scientific viewpoint, I think we really have to try to communicate this better, but also to get into a discussion. It's challenging because it's what we don't want to do is preaching our science to the public. Discussion and also acknowledging viewpoints from the public. I can understand that people could be afraid of this information, because it's if I look into this simulations, I'm alert, and I'm really as well how the future might look like. So I think it's a lot of psychology, how to interact, how to communicate that in a way that is really beneficial to all participants.
Andreas, we appreciate your time and we appreciate your research, and any way that we can help you guys out, you let us know. I would like to extend an invitation to you to maybe mention any websites or social media sites that our followers or listeners can reach out to you or even learn more about your research.
So I have a personal website, which I have to look up. So, and what I would say is really take a look at NCAR's website, especially Atmos News. So there is Atmos News is the platform where NCAR is highlighting research for the media and for the public. And this is a really good resource to find new research online.
Yeah, and to add to that, I think NCAR Atmos News has a Twitter, because I think I just followed them today.
So I think this is a very good resource for Twittering as well. So I just bring up my website here for a second, where I also try to highlight recent research. So I have like a media section on press releases, publications, and also contacts here that you can approach me and ask questions, get into a dialogue. And I'm really I would be really happy if people would use this tool to get into contact, get into this discussion, and get the word out.
Very cool. We'll see if we can get James, our tech guy, to link your website onto our podcast here as we put it up on our website. But we appreciate your time, and hopefully we can have you back on the show sometime soon with some new research.
Yeah, this would be great. Yeah, thank you so much for having me. This was a lot of fun.
Thank you, Andreas. Have a good evening. Feel free to stick around if you want to. We are, since we're a little bit after 9 o'clock, going to switch to our tweets of the weeks before we end our show. So, does anybody have theirs ready to go to share?
I can share that video I was just talking about if you'd like, Scotty.
Yeah, James. So James has been really honing in on the California fires and then the intense rainfall they've had this week. And James, you found some good video out of some of the Southern California area.
Yeah, that's right. And I think it was Ashley who mentioned it on our air last week that as soon as these heavy rains came into California in the areas where they have had those wildfires, that we were going to potentially see something to this extent. So we were just looking at some of our latest wire video here, and we do have some footage that came in. This is the Coast Guard. They're in Southern California. This video was released yesterday and recorded yesterday. So we have a Coast Guard MH-60T Jayhawk helicopter, for those of you who are into aviation, over a home here where they are rescuing a family of 5, including the mother, father, their newborn, a 7-year-old son, their 3-year-old daughter, and 2 dogs. This is in Santa Barbara, California, after the house was overtaken by the mudslide that you've been hearing about in the headlines, that has unfortunately killed several people, and dozens more still remain missing at this hour as officials try to comb through those mudslides. So the family that we're seeing in this video was transported to a staging area where they were assisted by emergency crews. We have another video that, if I were to fast forward this, it's a similar story. I'll let this one play out, but in that second video, it's another large family, 8 people and 5 dogs, all can be seen getting onto the video there so that the Coast Guard could help them get out of their neighborhood after the mudslides made area roads impassable. So lots of search and rescue and recovery efforts continuing tonight in Southern California, so we certainly keep those people in our thoughts. Scotty?
Definitely so. A sad situation going on out there, and it seems like they're dealing with so much with the fires and now with the flooding and the mudslides. They just need a break out there. So hopefully they can get some calmer weather out there. So thanks for that tweet or video of the week, James, and we'll toss it around. Let's see. Shay, do you have yours ready, or Eric?
I do, actually. Let me go ahead and pop that up. This is for all the folks that don't quite understand what black ice is and how dangerous it can be. This is from County in Virginia, and this is from Kelly Bessiker. Her husband, Tim, went out to his car to go to work that morning. This was January the 9th, and found quite a surprise. So I'm going to go ahead and play this, and I'm going to blow the screen up, and you can see just how, he's going downhill right towards the main street with cars going by. He ate it pretty hard in the grass. I'm not going to lie, but the good thing is that he's okay. His wife said he's fine. But that kind of thing, you can get hurt right there. I mean, it's almost like a curling episode you'd see in the Olympics. I mean, he did pretty good. I thought he did pretty good.
I give him about a 7.5.
I'm impressed he didn't take the mailbox out behind him.
Well, yeah. I mean, once he started heading towards the street, you could see those feet shuffling.
Well, I'm going to so we got Eric's up. So Eric, go ahead.
Okay. All right. So we're getting some winter weather on Friday, but for some people here in the area, this is not the actual first winter weather we've had this year. This is a tweet from Weather Service Memphis back on January 1st, the morning, New Year's morning. Some of us were up just early enough to be able to catch what actually turned out to be, in this very cold Arctic air mass with strong north winds blowing, lake and river effect snow across West Tennessee, and it actually extended down to North Mississippi. And this is a video, but you really can't tell that it's moving when it's going through here. But basically, up here in the center of the screen, right on the Tennessee-Kentucky border, this is the land between the lakes, or Kentucky Lake. It's a big recreational area, pretty large lake up there. And you can see the streamer of clouds that extends all the way down through West Tennessee and actually down into northern Mississippi. And then over here, close to the Mississippi River, Memphis being right downstream from that, there's a couple of other streamers through there. And actually, even here at my house, we had some flurries that were up in the eaves of the roofs around here. And they are suspecting, and I tend to agree with them here, that we actually got some river effect snow from the cold air blowing over the warm Mississippi River and creating that streamer that went right down through the middle of the city here. So pretty cool event. We don't see this very often, but every once in a while, enough cold air in this time of year to be able to see something like that.
Yeah, how about that, Eric? You don't even have to go anywhere. You just let high pressure work its way in.
Exactly right.
That's amazing. Ashley, do you have yours ready?
I think I just pulled it up. You guys see it?
Not yet.
Every time I try to do that, it asks me for permission. Okay. How about now?
You have permission.
All right. So as you guys know, AMS is going on this week. I've been glued to Twitter trying to read all the slides, the presentations. The theme for AMS this year was communications. So how are we talking about weather risk to the community, not only the general public, but also our highly vulnerable people? So that might be colorblind, deaf, things like that. And this tweet from Morgan Abigail was from a discussion from Bolton, which they actually did a study and showed what NWS's color scale would look like to a colorblind person. And it's very scary. If you take a look, a lot of the colors look the exact same. So if I'm colorblind to certain colors, I might see your warning as the same as another type of warning. So I thought this was kind of a awakening call for us to try to remember to plan and just explore how we can notify different kinds of people when we might just not think to do that kind of thing. So
this is not a pun, Ashley, but that is very eye-opening to really drive the point home. I couldn't think of a better way to describe it, because you're right. And for anyone who's listening to our podcast, we're looking at blues and browns and yellows, and you've got like 8 yellows that are the exact same color.
Mm-hmm.
I will say from personal, this does affect me. I'm some colors I can't tell, different shades and stuff. So I'm totally on this, and I actually reached out to Bolton, the guy who was giving this presentation today, on Twitter, hoping to get him on our show to talk about this, because it's something that really interests me, and hopefully we can have him on sometime this year to talk about that. But it's a real problem, I think, for me, especially when you got these winter weather advisories and stuff, and they all kind of blend in as the same color, and it's not good. So definitely needs to be addressed.
Exactly.
All right, well, I'll screen share my tweet of the week. I'm working with a new computer, so you got to give me just a second. All right, can you guys see mine?
You are good to go, Scotty.
All right, so this is from Montana Eck. He's a student at Appalachian State University, and it's been so cold around here. We've not really had any wintry weather to deal with, but we did have 8 straight days of temperatures below freezing, and so numerous waterfalls throughout western North Carolina just froze up. And this is actually the Tom Creeks Falls waterfall up on the Pisgah National Forest. Shay, you may have went by this when you were evacuating from the hurricane earlier this year. This is in northern McDowell County, but again, this is completely froze over. I have noticed, though, in the past couple of days, those ponds and water fountains and stuff like that are starting to thaw out a little bit, but amazing videos and pictures. Little plug here. If you go to the foothillsweathernetwork.com, we have a gallery up of numerous waterfalls and stuff that have been frozen throughout the past week from the wintry Arctic cold weather that we've had. So that was my tweet of the week, was the frozen waterfalls. So if you have a tweet over the week or something you would like for us to look at, tag us on Twitter. We'll definitely love to share that out. And before we close our show tonight, I want to give you an update on our schedule. Next week, we're going to be talking about kind of going hand in hand with what we talked about a little bit earlier, the opposite of that, forecasting wildfires from drought. So we're going to be talking with Todd Lindley. He is the Science and Operations Officer at the the National Weather Service in Norman, Oklahoma. He'll be joining us next week as we talk about forecasting wildfires. The next week, we'll have Weather and Art. Samantha Burks will be joining us. She's a meteorologist and an artist, so she's kind of combined two passions together. Shay was able to do a test hangout with her last night and said that she has some really awesome paintings and stuff like that, so can't wait to talk about that. And as we end up or round out the month of January, we're going to be continuing our hurricane theme and recapping Hurricane Irma. We have Matt Moreland, who was at the time the meteorologist in charge at the National Weather Service in Key West. He will be our guest. He's now in San Diego, but he was in Key West during Irma. So he'll join us and talk to us about Hurricane Irma and all the effects on the Florida Keys. So that is the rest of our January schedule. As always, if you have any guests or any certain topics you'd like us to talk about, send us a tweet or a message, and we'll get on to working, getting that on the schedule and get some guests lined up. So with that, you guys have anything before we close? All right. Well, thank you for watching the Carolina Weather Group. We hope you have a great weekend. And if you're in the Memphis area, stay safe out there during the ice apocalypse. Stay off the roads and follow memphisweather.net. Eric and his crew will keep you up to date. And we'll see you next week here on the Carolina Weather Group.